Have you ever been hiking up in Monroe and thought, how on earth would mountain rescue find me if I were to get lost? No? Well, I always have. So today I hope to shed some light on a model that I'm developing to help them find us faster. I'm doing this by simulating lost people moving over the landscape using psychological profiles to better predict their location. But first of all, what is a profile? A profile is a statistically significant grouping of people from historical data collected by agencies from all around the world. These profiles include solo hiker, child, or elderly person with dementia, as well as many, many more. We use the location found category to inform our model on which land location to target as it walks across the terrain. This allows us to adapt our model for the profile at hand by using the relevant location found data as an input weight. By running this model in a Monte Carlo manner, which basically just means running it hundreds of thousands of times, we can use the paths to infer the probability of where a lost person could be. A core part of this research was a validation of the model over multiple start locations. The problem is that even with decades of reporting, there's a severe lack of position data. A solution to this is randomly generating last place seen locations. However, just isn't very representative of a real world scenario. To get around this, we received a small data set from Scottish Mountain Rescue with around 300 locations. We upsample this dataset using supervised machine learning, as this method is very good at inferring trends in sparse data. You can see some of the results on the right. In the map above, you can see the paths taken by a simulated missing person. These converge on the previously mentioned location found positions, which is exactly what we want to see. The bar graph on the bottom shows 3 datasets. J2 is the latest model from our current work package, and original is the dataset that we want to match as closely as possible to. J1 is previous work. Using a divergence metric, J2 is calculated to be almost 5 times as good as J1 in showing real progression towards a true generalized model that we can use anywhere in the world. In future work, I will be focusing on using this model to then create drone paths to search the area even more effectively with the aim to further shave off precious seconds. Thank you.